This video is to help you get through the May 15th worksheet. So part A says, what's the expected value of the lottery, which has a 1% chance of reducing Mark's household to $20,000, his wealth. So expected value is 1% times 20,000 plus 0.99 times 80,000. That's 79,400. 79,400 was the expected value. The expected utility is as follows. It's equal to 11.276. Part C asks for if he received the value in Part A for sure, what's his utility? And the utility therefore would be the log of that number. So the log of 79,400, which is 11.282. So in other words, it's slightly above Part B, which means that he prefers having 79,400 for sure compared to facing the risk, which has the same expected value, which implies that he's risk averse, and therefore he has a declining margin utility of wealth. And that's Part D. Part E asks for the insurance premium and how much Mark's expected utility is if he's paying X dollars a year for insurance. So in that case, his expected utility is as follows. It's a 1% chance that his wealth is reduced to $20,000. Let me rephrase that. So it's a 1% chance that the tornado comes, which means his wealth is reduced by $60,000, but then he gains 60 right back from the insurance company, and then he also pays X dollars in premiums per year. So that's the state of the world if the tornado comes through, and the state of the world if there's no tornado, which happens with 99% probability, is simply that he has a wealth of 80,000, but he's guaranteed to pay X dollars per year as well. And so that actually simplifies to simply log of 80,000 minus X. If Mark is indifferent between his expected utility without insurance and his expected utility with insurance, then that implies a mathematical statement. I realize this question is worded slightly awkwardly. I think what I meant to say is, if Mark is indifferent between buying insurance and not buying insurance, what premiums must he be paying? In other words, what's the most he's willing to pay for insurance? So to set that up, that means he's indifferent between his utility without insurance and with insurance, which means we solve for the premium that makes him just indifferent. So we solve for the premium X, which makes this equation hold. And if I solve this, I get the following. E to both sides, subtract that number from 80,000, you get $1,101. So that's the most Mark's willing to pay for insurance. And then to graph this on a utility of wealth or this wealth axis and showing the certainty equivalent, you do the following. So put the two possible states of the world on the wealth axis and draw a chord between them. The expected value of this lottery is just slightly below 80,000, so I'm going to have to exaggerate so you can see it on this graph. So I'm going to say the expected value is actually here, and therefore to find the expected utility, we draw a vertical line up, and therefore that height is our expected utility. So that was 11.276 from before. To show the certainty equivalent, we say what level of wealth for sure gives him that level of expected utility. So, for example, this level of wealth, say 30,000, gives him that level of utility. Clearly not enough. So we want the level of wealth, which is right here, and that level of wealth gives him that level of utility, for sure. And so this level of wealth is just is the inverse log, or e, to 11.76, which is $78,898. So that's the certainty equivalent. And of course, it is $1,101.38 less than $80,000, which means that's the most he'd be willing to pay for insurance. If he had to pay more than that, he'd be better off. In other words, he'd have a higher expected utility. He'd be better off just facing the risk himself. But if an insurance company was willing to bear his risk in return for a premium of less than $1,101.38, then Mark is better off, and so he would buy that insurance.